Dividing complex numbers. Before we go on to dividing complex numbers, we need to review what a conjugate is. A conjugate is for every term a plus b I, we have a minus bi. So when you multiply the conjugates together, which we did in the very last video of multiplying complex numbers, we get a squared plus b squared. So the shortcut is you square your a's and you square your b and you add them together, and you don't have any more i's, which is essential when we divide complex numbers. When we divide complex numbers, we're actually rationalizing the denominator. Because I is square root of -1. So essentially when we have an I in the denominator, we have a square root of -1. So when we rationalize the denominator or divide complex numbers, we use the conjugate of the denominator, or find the conjugate of the denominator, multiply the numerator and denominator by the conjugate. 3, right answer in the form of a plus bi, or a minus bi. And I'm pretty lenient about this because I have seen answers not written in this exact form where you have a real plus or minus a imaginary part. So I'll show you what I mean on this. If you're my student, I take either way. So let's look at some examples. First off, let's look at 2 minus 3i over 4i. In order to get 4i, or the I out of the denominator, remember I squared equals -1. So if we multiply the denominator and numerator by I, we will get I times 2 minus 3i all over 4i squared. Well, that 4i squared becomes a -4, thus eliminating our I in the denominator. We will have 2i minus 3i squared in the numerator. The -3i squared becomes +3, so we'll have 3 plus 2i over -4. This is okay if you want to keep it in this form, or we will have -3 over 4 plus 1/2, or not plus, that will have to be a negative, because this will be 3 over -4 and 2i over -4. 2 over 4 becomes 1/2, and then our I. So this is actually in the a plus bi form, where I have accepted this form just because I wanted to make sure that students get the basic concept of rationalizing the denominator. So either one will work. Some professors are very adamant about writing it in the complex number form. Let's work on one more of those, and then we'll get into the complex numbers. So we have 4 minus 9i all over -6i. In order to eliminate the I, we can multiply the numerator and denominator by I, thus giving us I squared. So then we'll have 4i minus 9i squared in the numerator all over, this will actually become a 6. -6 times -1 gives us a 6. That will give us a +9, so 9 plus 4i all over 6. This is an acceptable answer, or give each part the denominator and reduce your fractions. Either one will work. Again, professors are very adamant about this correct form. Let's use the conjugate. So 1 plus 3, or 1 over 3 plus I. So we need to get rid of I in the denominator. Well, if we just multiply by I, the 3 will then have an I, and we didn't do much about our fraction. So we must multiply by the conjugate. So we'll have 3 minus I in the numerator, because 1 times this quantity is that quantity. When we multiply by conjugates, we'll have 9 plus 1. So we'll have 3 minus I over 10. Or 3 over 10 minus 1/10 I. Just give each of those parts the denominator and then reduce fractions. But either one is an answer. We'll have 2 over 5 minus I. Multiply by the conjugate. That would be 5 plus I over 5 plus I. So multiply by the conjugate, so you have to multiply the numerator and denominator. So we'll have 10 plus 2I, which I shouldn't have distributed that. I should have just left it as 2 times 5I, just in case if we can reduce the 2. 5 times 5 is 25. 1 times 1 is 1, so we'll have 10 plus 2I over 26. And I had that feeling. If we go ahead and keep it in factored form, or factor out the 2 again, that's supposed to be an I, sorry. Then 2 goes into 26 13 times, so we'll have 5 plus I over 13. To write it out in standard form, give each value a denominator. Okay, one more, and this will have multiple complex numbers. So to get rid of our I in the denominator, multiply by the conjugate. Because again, if you FOIL it out, you can see that our middle terms cancel out. So that would be 2 times negative I and positive 2 times positive I. So 2I minus 2I, that cancels out. And that's what we want. So whatever you do downstairs, you have to do upstairs. So let's multiply this out. 6 minus 3I minus 2I plus I squared all over 4 plus 1. And the reason why it's a plus 1 is because we'll have I times negative I, which is negative I squared. Remember, negative I is actually, or excuse me, I squared is actually negative 1. So the opposite of negative 1 is positive 1. And this will always be positive as long as you have your i's in the problem. So this will be negative 1. So we'll have 5 minus 5i all over 5. And then the 5's all cancel out, leaving us with 1 minus I. Okay, when you cancel the 5's, make sure you cancel all of them, or you could have factored out a 5 in the numerator and had 5 times the quantity, 1 minus I. Or 5 over 5 minus 5 over 5i. Those will turn into 1's. This concludes this video.